Okay, here's a little more detail on finding the derivative. We do want to start by realizing that when you have x to an exponent where there's an x in there, you usually want to use logarithmic differentiation. We also use logarithmic differentiation for complicated expression involving multiple products and quotients of functions of x. Because you can use properties of logarithms to make it easier. So we're starting by taking the natural log of both sides, and the reason we can do that is because the logarithmic function is 1-to-1. So if two numbers or expressions are equal, their logarithms are equal. And then we use, for right here, we use the properties of logarithms to bring this exponent down front. That's what we're showing right here, is the power property of logarithms. And here is that property right here. You've got the log of a power, you can move the exponent down front. We can prove that using properties of exponents in the definition of logarithms. And then here I just rewrote this as ln of x over x. Now we're going to take the derivative of both sides, and the key is the derivative of ln of y. Remember, when you take the derivative of ln of anything, it's 1 over the anything times the derivative of the anything. And that's because we're using the chain rule. So for example, over here, the derivative of ln of x squared is 1 over x squared times the derivative of x squared. That's the chain rule. The derivative of the inside is 2x. Of course, this would reduce to 2 over x for that example. And so over here, the derivative of ln of y is 1 over y times, we don't know what y looks like. It's a function of x, and I could also call this dy dx if I wanted to, instead of y prime. Okay, and on the right side, we use the quotient rule. The denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. And that becomes 1 minus ln of x over x squared. Now we still have this y over here. I have to multiply both sides by y to solve for y prime, or solve for dy dx. So we have 1 minus ln of x over x squared times y. But you know what? Y is x to the 1 over x power. I could put the y there if I wanted y prime to be defined in terms of x and y. But if I only want it in terms of x, I replace y with its definition. So there you go. That's the derivative of the original function. It's for a formula for slopes of tangent lines to the graph of that curve right there. If you wanted to, you could say, well, you know what, I'm doing a division of powers with the same base, so I could subtract the exponents. So I could rewrite this if I wanted to as x to the 1 over x minus 2. And if I wanted to, I could get a common denominator there and rewrite that exponent. There's just a lot of different forms you can put that in. But there you go. Hope that helped. And if you have any more questions, post a comment.